Welcome to our first tutorial, like a new tutorial on how to make a side-scroller game with a new Overlap2D editor. Many things have changed, and we're going to learn how to do a game from scratch using new technology and our new runtime and new editor. So yeah, before we start, I'm going to show you that we're going to work with those images. And some of those images are just simple images, and some of those are 9-patch images. And but before we get there, let's visit the libGDX website and download the setup application, which will help you to create your sample project. So we just run the application, and let's choose some sample name for our platformer tutorial. And some package name and the class name. We're not going to use the Android, iOS, and HTML projects for this tutorial, just to make things simpler, but obviously you can. It will still work. And yeah, I created a folder to place our project in. So we're going to use the latest libGDX 1.6.4 at this moment, and enable Box2D, free type fonts, Overlap2D extension, Ashley, which is an entity component system, and AI. Why not? Maybe we'll use it later. So let's generate our project. This will kickstart the process, and it takes some time. It's going to download everything from Gradle and do some configurations. And while we're at it, so these are the images we're going to use for creating our simple level. And you see the platform is kind of a 9-patch image. If you don't know what 9-patch image, let me show you it on an example and create a new 9-patch from this item 1, which is a pillar. So go to your Android SDK and tools folder, obviously you probably have that, and go to draw 9-patch bat file. And it will run the 9-patch application. That what it does, basically, you can specify which parts of your image are stretchable and which part should stay as is. So if we do like this, make it smaller, and from the other side. Now if you look to the right, the pillar is kind of stretched, but not entirely. Only the center part is stretched, and the other parts are kind of just right. So that is what 9-patch does. So we're going to save that, and it's going to add some data to the PNG image to specify the location of the non-stretchable and stretchable areas. It's important to name your file with a .9 at the end, so that libGDX will recognize it's a 9-patch image. Okay. Now our libGDX project setup tool is finished as well. There is some instructions on how to run that. What we're going to do is to copy that location and go to our IntelliJ, or if you're using Eclipse, then to your Eclipse. And I'm going to just import that project from existing sources. Just paste the location, and it should be a Gradle import with the default Gradle wrapper, and this takes some time as well. Meanwhile, let's head to the Overlap2D website and download the latest Overlap2D. At this moment it's 0.11, it's the latest one, and it's pretty different from what you've used before. So I'm just going to put that on my desktop and extract it. Archive. Just in this window. Our sources are ready, and our Overlap2D is almost ready. So let's fire it up. It's our demo project loaded. We don't need that. Let's get back to our libGDX application. first of all, you have to do Gradle Refresh just to make sure things are right. And now if you go to the Gradle tasks of the desktop, other, and click run, it should just work fine. This is the default libGDX application. Okay, let's create a new project for Overlap2D. Let's call it a platformer tutorial, and the size is okay. It's a pretty big size. For the pixels per world unit, I usually do 3 pixels. You can do whatever you want. So this is our new project, and we're going to import some images there. Our new import dialog is pretty easy to use. You can just drag and drop images there. So we're just going to do that. Just drag and drop it there, and ta-da, it's imported. Let's close it, and we can drag and drop things to our scene. As you can remember, these are 2 9-patch images and 2 simple images. So this says 9-patch right there. So if we take a transformation tool and do this to the right, it should transform just right, and this goes up and down freely without stretching, and this even goes up, down, left and right, so it looks like a table. Okay, let's delete those. And for simple first run, we're just going to put this image there and see how can we set up our application to just load it and display it. First of all, what we need to do is to export our images to our coding project. It's they're supposed to be in the core assets. If you have an Android application and it's in Android assets, right now it's in core assets. We're going to delete the bad logic logo from here, as well as delete some other not necessary stuff. So let's just import, open the files, and first of all, let's configure our application to have a window size, which in this case I like to do 800 for 480 because it's convenient to run on my screen. It's kind of not too big and not too small. And we're going to delete this image things and just left this. Currently it renders screen in red, so we're going to change that to black, and if we run it, it's just a black screen of our preferred size. So the assets folder is currently empty. As you can see, we wanted things to get here, and there's nothing here. So what we're going to do is we're going to kind of set the location for the export to the correct assets folder, and then press Ctrl E or the export button, and what will happen is our files will kind of get here. And you can see them in your IDE as well. Now if we run the game, nothing will happen because we don't do anything with those assets, but we finally have them in the right place. So the other thing I wanted to do is to go to the build Gradle file, and you can find the Overlap2D runtime loaded here, and libGDX put the 0.10 latest version here, but we're not, for the purpose of this tutorial, we're going to use a 0.11 snapshot. When you're watching this tutorial, there is probably an even newer version, or the 0.11 is not a snapshot anymore, but at this moment it is, so just check the latest version and put it there. And now just let's start setting up our runtime. Let's create a scene loader. Everything starts with a scene loader. Scene loader loads scene, as you can guess, and scene loader, the default scene loader takes nothing, and then you do load scene, and we're going to write main scene here. The main scene is you can see it's the default scene that is created when you create a new project. It's called like that. And the other thing we need to do, let's put the scene loader kind of up so we can access it in the render. The scene loader will create, it has the engine, which is the Ashley engine. I'm going to talk about it later. And we just need to call the update of the Ashley engine and pass it the amount of milliseconds, seconds passed from the last run of the render method. What we can see here, the image is kind of small. It should be bigger. The reason for that is because we're using world units, and the size of our world is not 680, it's in the world units, and we have 3 pixels per each world unit. Now to imagine the correct size of the things we want to kind of render on our camera in world units, let's first switch to the pixels and use rulers and guide system to kind of make our imaginary screen boundaries here, just for our for us to calculate things. So it's got to be 480 in height, and then it's going to be 800 in width, so something like that. And this goes to 0. Yep, so we got here a convenience square for us, and you can see in world units it's something like 266 on 260. So let's remember that number, and the next thing we're going to create is a viewport. Viewport is basically something that holds the camera. So we're going to create a new fit viewport. The reason is the fit viewport is taking the size of the world width and world height in world units, and we're going to pass the numbers we just took, and let's give it to scene loader. I do remember scene loader is taking the viewport as a parameter for load scene. Yep. So yeah, that goes after load scene. And if we run it now, things have correct size. So it's important to set up your world right. Let's move it to the center, hit Control E. And when we build it, it's in the center, rendering nice. Okay. So the next thing we want to do is kind of start building our level. I'm going to use this table kind of thingy as a ground item. Let's stretch it to the right a lot. Okay, just a little right. Okay, we don't need those rulers anymore. Rulers are unnecessary right now. Okay, let's put it right, and I want to put some platforms for us to jump later on. Some kind of a stairway, I guess. I'm just making this up. We're gonna do whatever when we get there. So let's just put this pillar here, maybe stretch it up and put a reward at the end or something like that. So let's export that and see how it renders. I think we want to move this a little bit down. I guess something like that will do. And the other thing is we need a player to play with. I'm going to use a ship animation from our original demo project. It's in the assets, original and sprite animations, ship, and we can import the entire atlas, which contains the frames, and it's now in the animations tab, and we can just drag and drop it here. Looking good. Let's run it up. Okay, forgot to export that. Just don't forget to hit Control E to export your assets, and it works. What we want to achieve is to move our character like right and left, and so we have to give it an identifier to then work from our code. So I'm going to write player right there. In the future, we also want to give either tags or identifiers to our other items so that we can do things to them. That's for later. So for the platforms, we can have a tag like a platform or something and then do collisions. But right now, we're just concerned with our player. And what we're going to do is to use an item wrapper in order to retrieve our player. Before we do that, let me just talk a little bit about what ECS is. Our new runtime is using an entity component system. In this case, it's called Ashley. It's written for libGDX. And what entity component system is basically entire world is composed from entities, and entity is kind of an empty object that knows nothing about itself. Luckily, it has things that are called components. So every item has a component on it that describes what it is. For example, in this case, the animation has an animation component that makes it an animation, and image is an entity that has a texture region component on it, so that it makes it image. Now, besides components and entities, an ECS have an engine that knows what entities it has and what components they have. So you can see in scene loader we get the engine and then call the update, so it does its thing. But the way it does its thing is via systems. So every engine has a systems attached to them that work with entities and components to make things happen. And in this case, for example, with a rendering system that does the rendering. So our engine will do whatever is required for runtime to operate. Now, you can read more about this, and you should read more about this on the Ashley wiki, which is on the GitHub. So just look it up and read more on how ECS works and what it is, because our new runtime operates with it. And it's pretty straightforward. You'll learn as we go. So at this moment we're going to create the item wrapper class, and what item wrapper does, it will help us to kind of retrieve our player. So we'll create the item wrapper root component that will get the root entity, and it will wrap around it for an easy access later. There is no necessity to use that, but it's kind of convenient. So now we have the root kind of item that we can, it's easy to do an hierarchical search with it. So we get child player, and now we have the player, and we can get the entity of a player, or we can add script for the player, which is exactly what we're going to do. At this moment I want to create a class for player logic. We're going to call it player, which is not surprising. I'm going to create an instance of it, like that, and we're going to feed it to the add script. Now add script is expecting something that is implementing the iScript interface. So player is going to implement the iScript, and iScript will just make us have some important methods like init, act, and dispose, so that there is the initialization logic, the iteration logic, and disposing logic. So we got to do that for our player. And first thing first is to just retrieve the entity that is the essence of our player. So we're just gonna get it in the initialization. Might be useful later. Now in our iteration we would want to do some kind of logic that will make our ship go left or right or move according to our commands. So on every iteration I want to kind of check if player what button is pressed at this moment. For that we do GDX input is key just pressed. Sorry, no, not just pressed. We need to do is key pressed, so it's always pressed. And we're gonna do keys left for the left button, and copy paste that for the right button. So at this moment we want to kind of modify the coordinates of entity, and the coordinates of the entity is kept in a component called transform component. So we need to retrieve it from the entity first and then work with it. Now to do that we're gonna do that in the initialization method, to do it just once and then remember it. So we're gonna do the transform component equals component retriever, which is the fastest way to retrieve components at this moment because it has a map of them, and you're gonna do get entity and then transform component class. So transform component has things like X, Y, scaling information, rotating information, and things like that. We're going to put it up to access in our act method, and we're going to change the X value. We're going to decrease it if you pressed left by 10, for example, I don't know what the right number is, and we're going to increase it by 10 if you press right. Let's see if that works. Let's run this, and it doesn't work. I guess I'm missing here something. Maybe I didn't export it. Let's hit Control E again and run it up. Yep, it works. And if we press right and left, it moves too fast, kinda. But we can slow it down, of course. So let's do that. Let's make a variable, a field called speed. That is a float. It's all about the horizontal speed at this moment. It's going to be 10f or something, and then we're going to replace those 10s with horizontal speed and multiply that by delta, because the speed is per second. So I suspect this is going to be super slow, which it is. So we have to make a bigger number, like 100 or something. How about that? And that looks okay. The only problem is we kind of go backwards when we go left. So in order to solve that, we're going to use a scaling property of transform component. So we're going to set scale x to -1 when you press left and to +1 when you press right. And at this moment it should kind of work as expected. So yay, we can go left, we can go right, and the last thing I want us to do in this tutorial is to implement the jumping. Now, okay, let's just move it a little bit down to the platform. Control S, Control E, and I'm going to ditch the horizontal speed and change it to vector, so we keep the both horizontal and vertical speeds there. So it's speed, and we're going to initialize it in our init method. So it's going to have x component as previous 100 and 0 for vertical speed. Okay, let's substitute it here, .x. Okay, the next thing we gotta do, we have to have gravity. So our gravity is something like 200, and it gotta be, it has to point down, so -200. And somewhere during our iteration, we have to lower our vertical speed by gravity multiplied by delta. So that is going to make an imitation of acceleration. So our speed, current speed y is minus equals gravity multiplied by delta. And now we have to use that speed information to actually transform the y coordinate of our player by the speed y, again multiplied by delta. Oops. So if we run it right now, it kind of loads up, because I think it has to be plus equals. Yes, because it's, yeah. So it will go down now. And I want to measure where it's currently standing, so we don't go it's a temporary solution. We're gonna do a better kind of raycasting and collision detection, but at this moment the best we do is just measure the current position of the ship, which is 7 world units on the y-axis. And basically if we go below that, so if transform component y is lower than the 7f, then our speed y should go back to equaling 0, and we have to go back to that position. So obviously this is a temporary solution just for the quick making it work quickly. So yes, it doesn't fall now, and what is left to do is just to do a simple jumping. So let's have a private final float jump speed. So this is the speed that we gain at the moment of jump, something like I don't know, like that. And so yeah, so if space is just pressed, so key space, then our speed y is directly equals to jump speed. It will be directly jump speed. It will fire up and gravity will start lowering it down, so it should look like a jump, but it kind of feels like on the moon. I think we can make our gravity stronger here and maybe jumping a bit weaker, so maybe 100 for this and 500 for this. Now it's too strong. Let's go back on the jump speed, and it's kind of right. So yeah, that's cool. So as you can see, we have a simple jumping, and for this tutorial I guess that's it, and see you in the part 2 where we cover more stuff. Thank you for watching.